Hello everyone and welcome to the AI Research Roundup. I'm your host Alex, and today we're diving into some interesting AI research. We'll be discussing a paper titled Evaluation Report on MCP Servers, which came out on April 18, 2025. Alright, so this paper looks at something called Model Context Protocol, or MCP. It's a way for AI models to safely use local or remote resources, like searching the web or a database. The authors evaluated how effective and efficient different MCP servers are, using a new benchmark they developed called MCP Bench, focusing specifically on web search and database search tasks. Alright, so they ran all these evaluations, and it's great to see they also released, well, the actual code for one of the key servers they looked at. This image shows the GitHub repository for the Xi'an MCP server. Remember? The paper mentioned optimizing the interface, particularly for database search. Well, this server is an implementation of that, using natural language queries instead of requiring the LLM to generate complex SQL. The repo has the source code, setup instructions, and configuration details if you want to try running it yourself with different databases like MySQL or PostgreSQL. Okay, so to evaluate database search performance, like with the Xi'an server we just discussed, the researchers used specific datasets. This table shows the two main ones they used for database tasks. First, there's CarBuy, which is a synthetic dataset based on car manufacturer data, with about 355 examples. You can see a sample question there about order numbers. Then there's SQL Eval, which uses 256 samples based on the well-known spider schema, but with new hand-selected questions. The example here is a bit more complex, asking about authors across different research domains. So, these datasets provided the ground truth for testing how well the different database MCP servers could retrieve the correct information. Okay, so we just talked about the datasets for database search. This image gives us a clearer picture of what these tasks actually look like, both for web search and database search. Table 1 shows a simple web search example, asking for Obama's middle name. You see the input question, the tool used, and the result, Hussein. Then, Table 3 shows a database task, similar to what we discussed with the CarBuy or SQL Eval datasets. The input asks for Tesla sales, but notice the tool requires a full SQL query. This is the standard approach, unlike the Xi'an server, which aimed to simplify this by taking natural language. Okay, so we just saw examples of the web search and database tasks. This table, Table 2, gives us the specifics on the datasets used for those web search evaluations. You can see there are three main sources listed. First is Frames, which is an open source dataset. Then there are two datasets the researchers collected themselves, called News and Knowledge, both in Chinese. Each of these datasets contains 100 samples, so 300 web search questions in total were used for testing the different web search servers. The examples show the kinds of questions asked, like about the FIFA World Cup, or a Tesla factory, or even types of fish. Alright, so after testing these servers on those web search datasets we just covered, like Frames and the News and Knowledge sets, this table, Table 5, shows the actual performance results. It breaks down how well each web search server did in terms of accuracy, how long it took, that's time consumption, and how many tokens it used, both pre-fill and completion. You can see there's a huge difference. Bing Web Search had the best accuracy at over 64%, while DuckDuckGo was much lower, around 14%. Time also varied a lot. Bing was fastest at about 12 seconds, but Exasearch took over 230 seconds on average. Token use was a bit more stable across the board though. So, clearly, not all MCP servers perform the same when it comes to web search. Okay, so this figure 1 gives us a nice visual summary of those web search performance numbers we just saw on the table. It plots each server based on its accuracy on the horizontal axis, where further right is better, and the time it took on the vertical axis, where lower down is better. Notice the time axis is logarithmic, so the differences are actually quite large. Ideally, you want servers in the bottom right corner, fast and accurate. You can clearly see the spread here. Bing Web Search is down there, pretty good on both counts. But then you have Exasearch way up top, very slow, and DuckDuck go far to the left. Not very accurate. It also plots the function calls like qin and Quark Search, showing they're right in the mix performance-wise. Alright, so that plot gave us a good visual overview, but the researchers also specifically compared the MCP approach to standard function calls, which we saw plotted in Figure 1 as well. This table, Table 6, zooms in on that comparison for web search. It shows results for Quark Search and qin Web Search, which are function calls, and compares them to Brave Search, an MCP server. Looking at accuracy, qin function call actually gets over 55%, which is better than Brave Search MCP at about 46%. Time-wise, Brave Search is faster, but qin isn't far behind. So, the takeaway here is that using MCP doesn't automatically mean better performance. Function calls can be just as good, or even better in some cases. Okay, so we saw that MCPs don't always beat function calls, but the paper also looked at how to improve MCP performance, especially for database tasks. This table, Table 7, digs into that. It compares the standard MySQL MCP server, where the LLM has to generate SQL, against the Xi'an MCP server implementation, which uses that declarative natural language interface we talked about. Accuracy goes up slightly, from about 54.7% to 56% with the Xi'an approach. It is a bit slower, but look at the pre-fill tokens, a huge drop from 2,800 down to around 415. So making the interface simpler for the LLM really cuts down the input complexity, even if it takes the server a bit longer to process. So overall, this paper gives us a really valuable first look at evaluating these MCP servers. We saw that MCPs aren't always better than function calls, and that how you design the interface matters a lot for efficiency, like using natural language instead of raw SQL. This kind of benchmarking is super important as we figure out the best ways for LLMs to interact with external tools and data. Alright, that's all for today's AI Research Roundup. Thanks for listening. I'm your host, Alex.